And this lesson is called Angle Pairs. Angle Pairs. So I want to talk a little bit about geometry as you're getting set up. All right, someone in the other class asked me, Mr. A, why do we always tend to finish our math year with geometry? I honestly don't know what the particular reason is, but it's a nice way to not add any more algebra, but to review algebra through a different perspective. So how many of you have siblings who've taken geometry or are taking it maybe this year? Okay. If I bring up one part of geometry that a lot of people don't like, and the part of it that people don't like, proofs. So if you want to get your sibling a little bit if you want to see their face change from happy to sad, just say geometric proofs. And the Christian, has he taken it or is he taking it? Okay. Oh, Anna? Hannah. I haven't had Hannah, but let's say I'm talking to Hannah. I'm like, Hannah, how'd you like geometry? I think it was okay. And then all I have to say is this: how'd you like proofs? And her face will go, oh, that's what I get. Oh, yeah, proofs. That's one of the hardest parts about geometry, but it's one of the parts that we have to understand, and we're going to start that up even right now. Okay, we're not going to actually write out the proofs because that takes a while, but we do have to prove what we say is true. Because if I tell you this is true, great, but I could be wrong. I have to be able to prove it and justify it, which you have been doing for a while. All right, how many of you like geometry? Just curious about, okay? How many of you hate it or don't like it? Okay, so most people like it or are indifferent. Some people don't like it at all. Okay, geometry and algebra today are going to come together because that's how they go. Geometry is a separate class from algebra, but that doesn't mean that they don't relate to one another. All right, can I give you another example of unrelated subjects? So geometry, algebra. English and math are separate subjects, right? They are unrelated. Is that true or false?
False.
That's a false statement. They go together. If you don't know English very well, then you're not going to understand math. You're like, wait, that doesn't make sense. Can I prove the point? Read the first paragraph of this lesson. If you don't know English, how well are you going to do? Not so well. Even just to start off with. We're going to go over 5 types of angle pairs. I'm going to use words to describe them. If you don't understand my words, how are you going to understand the mathematical concepts? English and math go together. So don't get confused, guys. Don't get into this mindset. Now I'm in math class. Nothing about language arts matters. History's out the door. Bible's certainly not in this classroom. You got to make sure that they all come together. And then I'm going to finish off with this. Why do they come together? Who created language? God did. Who created mathematical principles that we follow and abide by and are submissive to? God. Who allows everything to happen in history, whether it's good or bad? Who allows it? God. If He's the author of every subject, then they have to be related somehow. And wisdom is saying this: I got to find out what that relationship is, because I don't always see it. And I hope we can see a little bit of that tie-in today. Okay, anyway, we're going to go to angle pairs. And we're going to talk about 5 different types of angle pairs. The first type you may have heard before, but we're going to call them complementary, however you want to say it. Complementary angles. What does the word complement mean? I can use it in a different type of sentence. Complement. You not compliment with the I. That means I compliment you. Good job. You're great. I love math. But what's complement with an E? Yeah, what do you think?
Add on.
Okay, very close. What's the complement of peanut butter? Jelly. You know, grocery stores, when you see peanut butter, what's going to be pretty close by? Jelly. So those are complements. They're complementary items. They go together. So complement here, I'm going to draw a couple angles and then give you a definition. So here I'll draw one angle, and then I'll draw a second angle. They don't have to be perfect, but these we're going to call complementary angles, because when I add the two angles together, do you know what kind of angle I get? If I combine them, I get a right angle. So we're going to put the definition of two angles. We're talking about pairs of twos. Two angles that add up to 90 degrees, which is also known as a right angle. So if you add them up, you get 90 degrees. So what's the word I want you to get with complementary? Or what's the number I should say? 90 degrees. Complementary, 90. 90, complementary. I'm assuming too much right now. Okay, what are we talking about in this lesson? Angles, right? Angles and pairs of angles. What's an angle? No, it's not a number. That's like, you can call the measurement of an angle is a number, but what's an angle? How many of you can show me an angle? Can you guys show me an angle? Yeah, good. Use your two hands, okay? Or your fingers. Not loser, okay. Okay, or like that. What's an angle though? What is that? What are you showing me? Two hands that come together? Okay. In geometry, you're going to go over some basic definitions. Points, lines, rays, angles. You know what the definitions of those are? They're convoluted. Honestly, I'm going to try my best to describe it, but even then it's going to be a little off. One way to describe an angle is the space between two rays that have a common endpoint. So it's the space in here. That's an angle. Okay, it's all right. Another way to describe it would be the distance between two rays with a common endpoint. So it's that distance. That's an angle. But what does that mean? Okay, I find it hard to give you a definition of an angle because I don't really understand an angle fully. Another way to describe it is all the points that are within two rays with a common endpoint. I don't understand that fully. Do you know what a point is? What's a point in geometry? Isn't it one of these? What is one of these? What is that? Do you know that when I put a little point up here, I'm actually not drawing an actual point? In geometry, a point is a location in space. Okay, you're like, well, that's easy. Like, point to a location in space. Go. Point. All right, so you're pointing to that location. You know what? My finger is too big to point to one single point. You know how many points I'm actually pointing at? An infinite number. All right, what if my finger is super small? What would happen? How many am I still pointing at? An infinite number. I can't even describe to you what a point is. It's a location in space. So how do you show it to us? With one of these, which is very hard to comprehend. Isn't that kind of deep? Like, kind of like, what are you talking about? Okay, that's how deep geometry goes. We're talking about space now. We're talking about objects. And it does get complicated, but I'm not requiring you to know that. It is good to know that it does get complicated. Okay, complementary angles. Then we go to the second type, supplementary. Anyone know what supplementary means, or supplement? Yes, they don't add up to be 90 degrees, but they do add up to be 180 degrees. That's our other special number. So I'm going to draw an angle here, and then another angle there. So here's an angle, there's an angle. Supplementary angles are two angles that add up to be 180 degrees. So two angles that add up to 180 degrees. So what's the key number I want you to get with supplementary? 180. What's complementary? 90. What's supplementary? 180. How do you remember that? You memorize it. You have to memorize it. If I say two angles are supplementary, what's the number that pops up? 180. If I say complementary, what's the number that pops up? 90. It has to be automatic. And there are different ways to remember that, but it's whatever it takes for you to figure that out. Here's one way that someone taught me when I was younger, and it's okay, but I'll just show you. That's one way to do it. So complementary is how many right angles? Complementary? I'm asking you in a different way. Complementary. How many right angles? One, right? That's a complementary. That's a 90-degree angle. Okay. This to me looks kind of like a C, right? Can you kind of picture a C? Is that okay? All right, fine. What does that look like? What letter, I should say? And S. How many right angles does that have? 2. Anyone see it? See how that's a C? That's complementary, 90-degree. Supplementary has 2 90-degree angles, which makes it a total of 180. So which one should have the greater degree? Supplementary. And complementary is the smaller amount. That's one way of doing it. I'm sure there's a song out there on YouTube where someone's jamming out to this. You find it, you figure it out, you memorize it. But you do have to know. Okay, that's one way of knowing it. I'm going to pretend you said 90 and 180. Okay, the third type. It gets a little bit, comes away from these two, 90 and 180 degrees. We're going to call them adjacent. Anyone know what adjacent means? Yeah, next to each other. It's adjacent. Most of you have, I think I've said this before, you have someone adjacent to you. Can you look at the person who's adjacent to you? Or the people who are adjacent to you? Sam, who's adjacent to you? Alex and Mary. Who's adjacent to you, Josiah? Okay, Gracie definitely, and I guess I'll make it very clear. Whose table is adjacent to your table? Let's go with Henry. Whose table is adjacent to your table? Close. Brad. And so adjacent means next to, and usually it means that they're touching. They're like next to each other to the point where they're sharing something in common. Hagen, is Jackson's table adjacent to yours?
No.
Whose table is adjacent to yours? Jack. Okay, so do you guys get they touch and they're next to each other, and that'll make it more specific. So here I'm going to give you, okay, here's an angle. And I'm going to do something like, oh, not like that. All right, I have one angle, I have 2 angles. Are these 2 angles touching one another? Yes. And you're like, how do you know that whether they're touching or not? Here's the definition. 2 angles that share a vertex. So a vertex is where they start, where those rays start. So they share that common vertex. So share a vertex and a common side. So do these 2 angles have a common vertex? Yes. Do they share a side? Yes. These are adjacent angles. They're next to each other. And you're going to have some problems where you have several adjacent angles right next to each other, but we're talking about 2 of them at a time. These are adjacent. Right here. These 2 are adjacent. Okay. That was not too bad. Then you get number 4. Vertical. Time out. Linear pair. That's my 5th one. Got too fast. Linear pair. So a type of angle pair is called a linear pair. And the reason we didn't put this earlier is because, so here's my straight line. Here's my other angle. Okay, let's see if you guys were paying attention. Darius, These two angles, right here and right here, are they adjacent?
Yes.
Why are they adjacent, Michelle?
Because they're touching.
And how do we describe that touching? They share a common and a...
They share a common side and...
Yep, so they have a common side and they have a vertex. Okay. What do these two angles add up to be? If you had the measurement of this angle and the measurement of that angle, they'd add to be 180 degrees. A straight line is always 180 degrees. Good. What's another name for this pair, this linear pair? In this case, supplementary. You see I can call it different things? Supplementary because they both add up to be 180. They're a linear pair because they are two adjacent angles that add up to, or no, I want to say it different. That are, because that'll help you with your definitions, that are supplementary. That's a better way so you guys can remember what supplementary even means. So what does supplementary mean? Matthew. Add up to 180. What does adjacent mean? Sophie.
They share the same vertex inside.
Good. They share a common side and same vertex. And those two parts, adjacent and supplementary, form a linear pair. Do you guys see how they're a pair on a line? That's another way of thinking linear pair. Okay, and lastly, number 5, vertical. What does vertical normally mean?
Up and down.
Up and down, yep. Vertical angles. Okay, what I want you to do is draw two lines that intersect each other at any point. So it doesn't have to be like that, but two lines that intersect each other at any point. And they don't have to be perpendicular, okay? These are not perpendicular. How many angles were formed when you have two lines intersecting one another? 4 angles, right? Just go ahead and show me those. 4 angles were formed. Okay, let's see who's paying attention. Eva, these two angles, all right, so you got this one and that one. Are they a linear pair?
Yes.
Final answer?
Yes.
Yes, they are. Gracie, why are they a linear pair?
Because they share the same vertex.
They're adjacent because they share. And do these two add up to be 180? Yes. Okay, good. Jack, these two angles, are they a linear pair? Okay, this one and this one. Why are they a linear pair, Brad?
Because they are two angles that are supplementary.
Okay, they're supplementary and they are, what's that other key word that we want? They're supplementary and adjacent. They're next to each other and they're supplementary. They're a linear pair. Okay. Vertical angles are across from one another. So can you identify which ones are vertical? Which one? Or ones, I should say. Tell me when to stop. Tell me when to stop. Please tell me when to stop. This one is vertical with what other one?
Stop.
Okay, I put those little tick marks because they're saying that those two are vertical. Do you know anything about vertical angles? They are exactly the same. They're exactly the same. So vertical angles, two angles that are, and we're going to use this word, opposite from one another. And then I'm going to put this little side note. Vertical angles are, here's a special word, maybe some of you know, they are congruent. You guys remember what congruent means? Or it means that two things are congruent. They're the same. Okay, they're the same shape and size, so here these two angles are congruent. Are those the only two vertical angles? No. There's another pair of vertical angles here, and they are right here. They're those two angles right there. What does vertical mean again? I'm confused here now. What's vertical usually mean? Up and down. These are not up and down, are they? They're side to side. Okay, if I could do this, I would highlight this figure, and then I would rotate it. Could I rotate it to where these two are up and down? Could I rotate it, right? But Mr. A, they're not rotated. Okay, the idea is that they could be. Look at this book real quick. Did you guys notice that the length is vertical? Okay, your length is vertical, right? Watch this. Keep your eye on it. Don't lose track. Uh-oh. Did I change the shape when I flipped it over like that?
No.
Did I change the shape? Okay, ready? Keep your eye on it. Same shape?
Yes.
Okay, just because I moved the orientation of the object, that doesn't mean I changed the different parts of it. Now watch this. Keep your eye on it.
That's supposed to be 2D.
Yeah, 2D. You can think of 2D. Or even like this.
Yes.
Did I change the shape?
No.
Think of it. Did I change the shape? No, I just reoriented. So with these vertical angles, yeah, you can think up and down, but it's based on how it's oriented. Just think of the word opposites. They are opposites of one another. And they're congruent, which means they're the exact same thing. Okay, ready? I'm going to prove that right now because I told you we would prove stuff. Okay, let's get some numbers here. This is 60 degrees. That far right one, or that right angle, is, not a right angle. But this angle over here to the right is a 60-degree angle. I'm making this up here. What other angle do you know automatically? Go. This one that is opposite is also 60 degrees. You also should know another one. Go. You should know another one. Go. 120. What? How's that 120? Do you know another one, by the way? 120. Automatically. If you knew one of these angles, you know all of them. You know how? We're going to prove it a couple ways. Ready? These are vertical angles, so I just said that they're congruent, but let's prove some things. What do these two angles have to add up to be? 180. What's 120 plus 60? 180. That works. What do these two angles have to add up to be? 180. So 180 minus 60? 120 again. Are these vertical angles? So what do they have to be? The same. Here's one we haven't talked about. From this point all the way around would get me what? 360 degrees. But that's not true. What's 120 plus 60 plus 120 plus 60? You're allowed to say the number? Yeah, if you add these up, guess what you get? 360. So did we prove that these must be the numbers? Did we prove it? We proved it a couple of ways. And then geometry, you're going to actually use some words to describe those proofs. That is later on. Okay. Whew. All right, let's look at some problems of actually applying these ideas. Okay. Any questions on the 5 types of pairs? That's a lot, but you can look at your notes. You can use your notes. I'm okay with that. Okay, let's look at this problem here. Draw this angle and draw this other angle. And they're not the same. They just look really close. And label these parts as well. This is angle F. This is angle G. Angle F and angle G. All right, if I say that angle F and angle G are complementary, does anyone remember what that means? Darius?
They together make
Yep, they add up to be 90 degrees. Great. All right, let's get some numbers here. 42 degrees, and this one's x over 2 degrees. What's the measure of angle F? Don't be confused. 42 degrees, good. What's the measure of angle G? It's x over 2 degrees, and I don't know exactly what that number is, but here's how I'm going to find it out. Guys, these are easy problems, by the way. It gets tougher, so please follow me. What do these two angles have to add up to be, according to this statement? So I got to do 42 plus x over 2 equals what? 90. How am I going to find out what x is? What's my first step here? Subtract 42 from both sides. You want to undo what's happening to x. You're going to be left with x over 2 equals, yes, 48. Then what do you do to both sides? Multiply by 2, and you end up with x equals 96. Does that make sense? It does. What's the measure of angle G? Okay, it's x divided by 2. What is x? What's 96 divided by 2? So what's the measure of angle G? It's 48 degrees. Not 96. Well, why do we have to get the 96? Well, sometimes the problem's going to ask you what's x? It's 96. And sometimes they're going to ask you what's the measure. Oh, sorry, that's a 2. Stuck in Algebra 1. Sometimes they're going to ask you what's the measure of an angle. It's 48 degrees. Do you see that there's a difference? What does x equal?
26.
What does the measure of angle G equal? Okay, so they're part of the same problem, but different aspects that you're looking for. Okay, next one. So be careful what they're asking for. Andrew, are these two angles, I'm just going to label them here, and look at it carefully. Are these two angles adjacent? What? Why aren't they adjacent? They're not touching. They don't share a common side. It looks like they do, but they're not together, so they're not adjacent. But these two angles, we're going to call this one H. We're going to call that I. So those are the vertices. Angle H and angle I are, you want to guess what you think they are?
180 degrees.
Because they're called supplementary. Good. So yes, they're 180 degrees together, but they're supplementary. So when they say they're supplementary, what's the number you think of? 180 degrees. Okay, great. So let's put some numbers to this. 126, and that's 2x. I want to find out what x is. So how do I find out what x is? What do these two angles have to add up to be? 180. So what's 126 plus 2x? It equals 180. Now I can find out what x is. So what do I do on this problem? First, I'm going to subtract 126, and this is review. What's happening to x first? It's being multiplied by 2, then it's being added with 126. How do you undo that? Well, you subtract, then you'll divide. I got 2x equals, 2x equals, okay, 54 I think I heard. All right, and then what do you do to both sides? Divide by 2. I got x equals 27. Awesome. X equals 27, but what does angle I equal? 54. So here, if they wanted this, you give them that. If they said, what's angle I? You have to give them this. So those are two parts of the same answer. How many of you are kind of getting this a little bit? I'm telling you right now, guys, it gets tough. So if you're following me, you should be okay. If not, it's going to be really bad. Yes, ma'am.
So, like, it says, like, when we did x over 2, we multiplied it by 2, and then it says
2x.
2x, so why did we just, like, leave that?
So here 2x.
Yes.
So we divided both sides by 2.
And then we got rid of the 2.
We got rid of the 2, yes. So sometimes you have to multiply or divide depending on what's happening. You want to undo. Yes, sir? Oh.
So say it was only asking for angle I, would you have to like get what x?
No, you just know it's right here because I know that 2x equals 54. That's what I wanted. Okay, good. Good questions. All right, let's do this one. This one's a nice diagram because you're going to see more of this on your homework. So draw a line. Draw another line. And then you're going to draw a few points on these lines and label the way I label it here because you're going to see this more on your homework. Okay, so I labeled all the points. I had 5 points up there and I labeled them all. And there's a reason why I label many points because it's going to have an effect. Okay, here's why we put so many points. Okay, if I ask you find angle O, what am I talking about? What am I looking for? Find angle O. Don't write this down. Don't write this down. But if I want an angle O, what am I looking for? Am I looking for this one? Or this one? Or that one? Or this one? Which one am I looking for? Yeah, that one. I'm like, yeah, that one. Okay, I don't know which one I'm looking for because I don't have enough info. So now if I ask find angle AOC, which angle am I talking about? Can you guys find it? AOC. I'm talking about this angle right here. You see how it makes it clear? Mr. A, but why can't you just use 2 letters instead of 3? Well, find angle AO. Find angle AO. So AO. Which one am I talking about? This one or this one? I don't know. So how many letters do we use when we have a lot going on? 3. So be ready for that. Okay, AOC. And, I forgot to give you some numbers. 3x plus 10. So that's AOC. It's 3x plus 10. And x plus 15. So that's AOC is 3x plus 10. And then do you know what do I name this angle that I'm labeling as x plus 50? What do I name it? Angle. Sorry, raise your hand. I heard a few things there. A few versions. Okay, Mary? You can name it BOD, also known as BOD. Or you can name it DOB. So it's either one of those. Okay. Sorry? Anyway, angle AOC and angle DOB are, go. What kind of angles? Vertical angles are opposites of one another. Yep, they're opposites. And what do we know about these opposite angles? They are the... Okay, good. I heard it even better. Someone said it. They're congruent. So they're the same thing. I know that 3x plus 10 is equal to x plus 50. Because these two angles are vertical. They have to equal one another. You're like, huh? Okay. Do you agree that this equals that? I mean, by what we said, and you're like, what do you do to solve for x? Many ways you can solve it. Some easier, some more difficult. How to get x by itself. Good. I think subtracting x might be your first step. To make it easier, you don't have to do that. But that's one way to do it. I get 2x plus 10 equals, those x's cancel out, equals 50. Now how do I solve for x? Once I did that, I hope it got a little easier. What do? Subtract 10 from both sides. You get 2x equals 40. And then what do you do to both sides? Divide by 2, you get x equals 20. Yay, I got x equals 20, and that is correct. What is the measure of AOC? Angle AOC. Go ahead and figure that out. I got x equals 20. Great. Angle AOC is... All right, Hudson, what's AOC?
It was 70 degrees.
Good, and he said 70 degrees. That's correct. All right, let's see if you guys can get this very quickly. Henry, ready? I want to answer right away. What is the measure of angle DOB?
What was the question?
What is the measure of angle DOB?
50 or 70.
70. Angle DOB is equal to 70. How do you get 70?
Because it's the same as angle A.
They're the same thing, right? And what's 20 plus 50?
17,
What's 3 times 20
16,
plus 10?
10,
So you got the same number? All right, ready? Who thinks they can go really quick on those answers? Like, you can just get it. Awesome, ready? What is the measure of angle COB? Go.
110.
What? How'd you do that?
Together,
Say that just a little bit louder.
I knew that angles AOC and POC had to equal 180 degrees, so I subtracted 70 from 180.
To get 110. Yep, these are a linear pair because they are adjacent and they form 180 degrees. All right, last one. Ready, Gracie? It's for you. What is the measure of angle AOD? 110 degrees right here. Can somebody tell me why, real quick? Because this angle is what with this angle? Vertical, so they have to be the same. And guess what all four, add up to be? 360. Yeah, you can check all of those. Okay. How many of you are ready for this? Okay, good. I like the attitude. 3 of you are ready. Your homework. Number 1's done for you. So just write the answer, but 1 through 5 all. And 7 through 11 all. You're welcome. 267. All right, guys, be careful on those diagrams. They're not friendly.